All right, let's talk about Clawdbot. Over the past few weeks, Clawdbot has quietly turned into one of the most talked about AI agent on the planet. It's open source and truly amazing. Many of you have probably seen demos of how it works, but in this video, I wanted to do something different. I'm going to look under the hood and share with you how Clawdbot actually works in simple terms. Specifically, we'll break down its three core pieces of design, the agent architecture, channels and tool use, and finally, how data and memory work. So at the heart of Clawdbot is a long-running agent runtime called Gateway, and each agent in Clawdbot is built around a concept called a workspace. A workspace is the agent's dedicated directory and contains key information the agent needs to operate. There's the agents.md, which defines operating instructions and behaviors. There's the soul.md, which describes the agent's persona, boundaries, and style. There's the user.md, which stores user-specific context. And finally, there's a memory.md, which represents curated long-term memory and memory logs that track what happens over time. The design enforces a strict one-to-one relationship between an agent and a workspace. Furthermore, Clawdbot supports a multi-agent system. User can define multiple agents in the config file, each with its own workspace, OS, and tool configurations and channel permissions. These agents can run in parallel and individually spawn sub-agents to achieve its task. Next, let's talk about channels and tool use. In Clawdbot, a channel is simply a communication surface, things like WhatsApp, Telegram, or Discord. Architecturally, every channel connects into the gateway service. Each channel or external app, when integrated, also defines its own set of agent actions or tools. For example, Discord might support reactions or pinning messages, while another channel does not. On top of channel-specific actions, agents also have access to a set of core tools, which falls into three broad buckets. Coding tools like reading, writing, editing files, execution tools for running commands and managing processes, and Clawdbot-specific platform tools such as browser access, canvas, operations, etc. And each agent can have different tool permissions and policies. Finally, let's talk about data flow and memory. Clawdbot separates data into three layers: configuration, which includes system-level settings; state, which includes runtime data such as active session conversations; and finally, workspace, which holds content for an agent. Long-term memory is stored in files like memory.md, and daily activity is locked in date-stamped files. For long-term memory retrieval, Clawdbot builds per-agent SQL search index on top of those files. This index supports vector similarity search and traditional keyword search, and then merges the result into a hybrid ranking. From the agent's perspective, memory search is provided as a tool. An agent decides by itself when to search memory, what to retrieve, and when to write new information. As conversations grow longer, Clawdbot automatically compacts